Hey folks, Farrak here. Okay, so if you go to the forum to off topic, don't go to K. Lupus's Think About This. Go to my thread. Where is it? Carrot Man, Think About This, okay? I wrote a simple mathematical statement, and it's a pretty cool statement. My last line is, God, math is so cool. And it really is. And many people had problems with what I said. They were asking questions back and forth. So I figured I'll end all of it and I'll give a very thorough explanation as a video. If you are completely bored with math and you're certain you can't possibly be excited by math, don't watch this. If there is a shred of you that might find this interesting, I think you'll find it actually pretty cool. So let me show you. First of all, let's start out with a very important question. What is infinity? So obviously you know the answer. Let's just put it in perspective. If you had the number 1, and then you put a 0, right? That's 10, 100, that's 1,000. These are big numbers. 10,000, 100,000, a million, 10 million, 100 million, a billion, a trillion, and you go on. And you put quite a few zeros there. And just imagine that if every person on Earth counted at this speed, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, every human on Earth collectively over 100 lifetimes could not count to this number that I have here. But let's keep on going. Blah, 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 blah. Okay, if you would do this, and these zeros would not only fill up this entire page, but would cover the entire Earth. These teeny zeros cover the entire Earth. It still wouldn't get even close to infinity. If you were to take Cheerios and sprinkle them all over the atmosphere so that they would engulf the entire world, and I'm talking from here to the moon, there would be Cheerios so densely packed you wouldn't be able to breathe. There would not be even close to infinity Cheerios, okay? Just putting that out there. Infinity is a very, very freaking big number, okay? So my statement was as follows. If I would write the number line, let's say I had a 0, right? And then, what's going on here? I had a 0. And then, let's just say a line, and then a 1. Okay? Now, keep in mind, the spaces here, right? This is smack in middle. This will be 0.5 or a half. We'll call it a half. Right? It's a half of 1, not 2nd of January, you stupid Excel program. 0.5, okay? This will be about a quarter, right? 0.25 or whatever. So you get how the number line works, right? Let's say this number line was stretched really long, okay? My statement was if you would take a dart, and it's not really a dart, I'm just doing it so that I could break it down to people who don't understand math so well. It's really just pick a number out of a hat, but let's use the dart example. If I would take an extremely thin dart and throw it at any point on the line, the probability that I would hit a rational number is 0. Now you might ask, well, Farrak, that's nice, but what the heck is a rational number? Well, I'm glad you asked. A rational number is a number that ends. So if I have 12 point, la, 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 and that's it, okay? And in fact, I'm going, see, you can see all the decimals. That's a rational number because you can say it, 12.32876, blah, 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 83. It ends. The number 0.0000099, that's a rational number because it ends. Anyhow, it's this scientific notation to keep it so that the computer will be able to retain it. Anyhow, any number that eventually has an ending point is called a rational number. So you might think, well, every number in existence is rational, and you're kind of right. But there are numbers that you've heard of called pi, which is, right, 3.14152, blah, blah, blah. This actually goes on forever, and if you would have the strongest computer in the world try to compute it, it'll keep on adding digits to the end of it, and it will never, ever, ever stop, because the number actually goes on forever. I'm talking infinity, baby. I'm talking those numbers will just wrap around the universe so many times your brain would spin. It doesn't end. That's pi. If you take the square root of 2, let's see what Excel does. Square root of 2. Excel rounds it off. It just gives an estimate. I wonder how far it'll actually go. It rounds it off till here, to like the 11th, 12th digit. But in fact, the square root of 2 never ends. And this 2, if you would take a calculator that's not stubborn and doesn't just spit out a number and stop, but it would actually calculate the full square root of 2, it would just go and wrap around the universe. It's a number that never ends. That's irrational, okay? So pi is an irrational number. Now, if I was to ask you, how many rational numbers are there on the number line? The answer is there are infinity many rational numbers. Let me explain to you why. There's 0. There's 0.000000001. Oops. Yeah, it doesn't like when I write those out. I wish it wouldn't do that. Then there's 0.0002. 0.000. Now remember, these zeros go on all the way, let's say, up to the moon. Okay? Literally up to the moon. We're talking billions and trillions of zeros and then a 1. But eventually it does end. It's still called a rational number. Well, how many of these numbers are there? Well, there are infinite amount of them. And you're going to say, wait, that doesn't make sense because it's not infinity, it's rational. Yes, this is a rational number, but now let's move on to the next spot, right? We're still here. How about 0.1 or whatever? And each time you move up another decimal, you add another billions and trillions of rational numbers. And if you add up all those rational numbers, they're just too many to count, and it becomes an infinite number. But once you get to irrational numbers, where the numbers go even past the moon and beyond and beyond and beyond, and they never, ever, ever, ever stop, those numbers are called irrational and go on forever. My statement was simply, if you would take a dart and throw it anywhere on the line, it was a super duper thin dart, and smack, you hit exactly a teeny little point, you would absolutely hit an irrational number. It's not possible. There is a 0% chance, a 0% probability that you will hit a rational number. Now, people on the forum didn't like this. They said, whoa, Farrakh, that's ridiculous. There are infinite many rational numbers, you just said. You go to the moon and back with the 0.000, finally a 1 at the end, so there's so many of them. There's got to be at least a teeny little chance that you could hit it. And this is where math gets really funky. And this is, if you are anything, even in undergraduate level math, and you don't understand this, you're perfectly normal, because this is graduate level math. It's really complex stuff. You're not supposed to really understand this. It's just a cool concept. So the answer is as follows. The probability of something happening. I don't want to get too much into mapping. That's too complex. Darn it, I knew this would get complicated. I'm like, oh, I'm Farrakh. I can explain things well. I'll explain this. But darn it, it's about to get so complicated. Okay, if you don't want to get complicated, leave now. If you want to hear me make a fool of myself, you may stay. Okay, there's something called a mapping. A mapping is like a function. If you've ever seen 2x plus 1, so whatever number you put in here, it'll do its work and spit out an answer. So let's say you put in 1. So now x is 1. So 2 times 1 is 2 plus 1. This will equal 3. Let's put the function over here. Let's say you put in 2 for x. 2 times 2 is 4 plus 1 is 5. So every time you put in something, it spits out another number, right? Let's say you put in 10 for x. 2 times 10 is 20 plus 1 is 21. So this is called a function. You put in something, it spits it out. Or another word for it is mapping. The word probability, which you just think, oh, the probability of something happening. No, it's a mapping. oh goodness, what did I just do? God, save me. Oh, here, back home. Oh, thank you. What on earth just happened? Oh God, this is so confusing. Okay, here. So probability is actually a mapping. It takes anything in the world and it maps it to 0, 1 land. What do I mean? Let's say you're flipping a coin. So there could be a heads or a tails. This is a real life thing. What are we doing? We're mapping it to 0, 1 space. What I mean is, what's the probability of getting a heads? 0.5. That's in between 0, 1. What's the probability of getting a tails? 0.5. That's the other 0.5. So 50% of this is the chance of getting a head. 50% of this is chance of getting a tail. Let's say I flip a coin twice. So my chances are I can get a head, I can get a tail, I can get a heads and then a tail, and I get a tails and then a heads. There are 4 chances. This also still maps back to 0, 1 land. But this time it goes to 0.25. This goes up to 0.25, this goes up to 0.5, this goes up to 0.75, and this goes up to 1. What do I mean? I mean each one of these gets a little section. The chance of getting a heads is 25%. The chance of getting a tails is 25%. The chance of getting a heads tails is another 25%. The chance of getting a tails and then a heads is another 25%. So if I asked you, what's the probability of getting any head at any time? So you say, well, there's a head in this case, there's a head in this case, there's a head in this case, but there's no head here. So you have a 25, a 25, and a 25. The probability is 0.75, which is also known as 75%. And there's a 25% of not getting any head. So it's a mapping. Every probability maps, okay? So we are in the 0, 1 space, which actually is not really 0, 1. It's massive space with so many numbers. It goes on forever and ever and ever. You have to remember that even though there are infinite many rational numbers, there are infinity raised to the infinity power irrational numbers. What that means is, for every rational number, and I'm talking a big dude, I'm talking for every rational number like, stop. There are so many irrational numbers after this that if I would display all of those on a piece of paper, you wouldn't even see this number. It would be so small. So if I was to fill up the universe with all irrational numbers that come after this 9 and this huge number, there would be so many ridiculous numbers going on after here. This example 9 with the 00001 and this 9 with the 00002. There are infinitely many numbers after this rational number that this rational number will get swallowed up whole and you won't even see it anymore. So the big question people are asking me on the forum is, but there still are rational numbers between 0 and 1. And my answer is yes, but for every rational number, there are infinite squared, infinite to the infinite power. There are so many irrational numbers after that rational number that that number will not even be seen when you map it back. Because remember, we're taking all these crazy numbers and pulling it back to this little number line. We're mapping it back to 0, 1. The probability of you hitting a number that can't even be seen because of so many numbers after it is basically 0. I'm not going to get into why it's actually 0, because it really is actually 0. But for you, I would rather not get into that complexities. I'll just say it's basically 0 because of how much it gets overshadowed by all the irrational number following it. That one statement is really important, so let me say it one more time. If you pick the most crazy rational number, that dude, okay? Look at that. We're going very close to infinity here. There are still so many more irrational numbers after here that this number you won't even be able to see it. If we covered the earth with all the numbers after this, there would be so many numbers after this that you wouldn't even see this number anymore. Which means the odds of picking this number out of a hat are 0. So sure, there are infinity many rational numbers on this line, but because for every one of those infinity many numbers, there are another infinity irrational numbers for that single rational number. That rational number becomes swallowed up and you can't see it anymore. So one more time, the probability of you throwing a dart and hitting that rational number, even though it's a massively ridiculous number, and there's so many rational numbers, there are infinity many rational numbers, as I said before, still, the probability of you hitting a rational number is 0. Because for every one rational number, there are infinitely many more irrational numbers than that single rational number. So that rational number gets swallowed up by the whole zoo of irrational numbers. Now I'm going to digress. I hope you understood that. If not, do not try to anymore. Your brain will explode. This stuff is really hard. Somebody asked me a question, which is sort of a silly question. He said, wait, if you're talking about a dart, right? The dart would have to be so thin that it could hit one of these numbers. And for the dart to be so thin that it could hit a number that doesn't really exist, the dart would have to be 0. So there's no dart at all. And that's actually right. There is no dart. I can't use the word dart because no dart could possibly be thin enough to hit these teeny little numbers in between this line. So the better way of saying this example is, what's the probability of me randomly picking a rational number out of this line? And the answer is none, because there are so many more irrational numbers that it just won't happen. I hope I thoroughly confused you. And by the way, people have been asking on the forum, what, are you a math teacher or something? I thought you work in a bank. Well, my history is about 10 years ago, I started undergraduate school and college, and I couldn't afford to pay for everything, my car, my gas, so I took up some teaching jobs. There was a private school that was desperately in need of a wacky teacher because it was October and already 3 teachers quit. So they took me. It was actually a really fun experience. I'm not going to get into the details. The kids loved me. I was out of my mind. I remember one day I stood up a 5th grade class and I said, whoever can guess a number that I'm thinking of between 1 and 500 gets what's in my back left pocket. And I let every kid in the class guess, and one kid nailed it. It was like 79. So I let him have what's in my back pocket, which was a $50 bill. And his mother called the school. She thought he stole it from one of the administrators of the school. She was furious at him. I had to explain that I gave it to him. The parents were like, are you out of your mind? Give me the money. Anyhow, yes, I was a wacky teacher. So I taught for 4 years. I taught undergraduate school, and I got I taught elementary school, and I got a very good reputation. They recommended me to other schools, and I started teaching high school math and other stuff. And eventually, now I'm teaching in colleges. I'm teaching programming and stuff of sort, but whatever. But the point is, I taught for many, many years, and now I just got a job at a bank, and I'm very happy here. Eventually, I'm going to want to go back and teach in college because I love teaching. But right now, all the money's coming from the bank, so we're going to just keep the bank happy. Yes, I do love math, and I hated, actually failed math all the way through 12th grade. Don't tell anyone. But then I suddenly in college got interested in it and studied really hard all the way from elementary school math all the way up to now, and I got really good at it. So it's cool stuff. If this blew your mind and you couldn't follow it, then congrats. Welcome to 99% of humans on Earth. And if it didn't, then you're probably really smart, and you should go on, get an advanced degree, make a ton of money, and make a Battleforge too. Anyhow, I'll see you guys in the next video.